We'll now continue our discussion of section 3.2, transformations of functions. We'll look first at vertical stretching and compressing. Let f of x be a function and let a be a positive real number. The graph of the function g of x is equal to a times f of x is stretched vertically compared to the graph of f if a is greater than 1. So what this is saying is that if you have a function say the squared function, and you place an a value in front of the x squared, multiplying it onto the function. If the a is greater than 1, for example 3, then that is going to cause the graph to stretch vertically. The second point says the graph of the function g of x is equal to a times f of x is compressed vertically compared to the graph of f if the a value is in between 0 and 1. So again, this is saying that if you have your function, and we're just selecting one to illustrate, we have the x squared function. If we multiply a number on the front of the function, and that number is in between 0 and 1, like say a half, then that is going to cause the graph to compress vertically. Let's look at an example. Sketch the graph of the following functions. In part A, ask us to graph f of x is equal to the square root of x divided by 10. Now, we probably want to look at this square root of x divided by 10 as being 1/10 times the square root of x, so that we can identify the 1/10 as being our a value, keeping in mind that that a value is in between 0 and 1. So we know in that case that we should be looking at a vertical compression for the graph. So if you look at the picture, here is the graph of our basic function, the square root of x. This is the graph for our root function. Now, when we multiply that function times 1/10, essentially what is happening is that you are multiplying each point along the line times 1/10. So you are making all of those points, all of those x and y values smaller. And so when that happens, the graph flattens out. It compresses itself from top to bottom. And the picture of the graph ends up doing more of this. And so this is the graph of f of x is equal to the square root of x over 10. Now, as always, if you want to be very precise, you would need to plot a few points. But generally in this section, we want to be able to know that multiplying by 1/10 causes a vertical compression, causes a flattening out of our graph. So let's look at part B. Part B says g of x is equal to 5 times the absolute value of x. So g of x is equal to 5 times the absolute value of x. And so again, you can recognize that the 5 is the a value, that it is most definitely greater than 1, which means that you should have a vertical stretch on your graph. So if you look at your graph, here is your graph of the absolute value function with no changes, just your base function. So now essentially what we're doing is we're saying that every number in that function is now multiplied by 5. So you put in an x value into this function, and you put the same x value into this one's going to produce a value that's 5 times higher. And so you can see that that causes the graph to stretch up and be taller than the original graph. And so again, if you want to be very precise, you want to use points. But in general, what you want to be able to do is to look at this graph and say, because we are multiplying each coordinate by 5, we're going to see a vertical stretch on the graph. The next thing that we're going to consider is that sometimes we have problems where there is more than one transformation happening within the same problem. What we've looked at up to this point has been a problem that is either a vertical stretch or a vertical compression or a horizontal shift or a vertical shift or a reflection, but not any combination of those in the same problem. If you have a problem where you have more than one transformation, the order that you look at those transformations in is important. The recommended order is that you deal with horizontal shifts first, then stretching and compressions, then reflections, and finally vertical shifts. So with that order in mind, let's take a look at an example. We're being asked to sketch the graph of the function f of x is equal to 1 over 2 minus x. So first of all, what we want to realize is that this graph is based on the graph of 1 over x. So let's look at how we started with 1 over x and we ended up with 1 over 2 minus x. So keeping your order in mind, remember that your first order is to talk about a horizontal shift. So let's consider that. Has there been a horizontal shift? So what I'm going to do, remember a horizontal shift means that we're going to replace the x with, and I'm going to replace that x with x plus 2. All right, so I'm just going to write over here. This is where we started with 1 over x. Then we're going to replace that x with an x plus 2, doing a horizontal shift to the left. Now I'm going to keep an eye on my original function. We're almost there. Our function is 1 over 2 minus x, and we have 1 over, essentially we have 1 over 2 plus x. I could very easily just sort of switch that ordering a little bit and make this 1 over 2 plus x. And so then the only thing that we need to do next is we need to somehow make it 2 minus x instead of 2 plus x. And so what we're going to do then is we're going to replace the x So I am going to take my function here and I'm going to erase the x, and in its place I'm going to put a negative x. And so when you do that, what is happening to your graph? If you replace the x with a negative x, then that's a reflection over the y-axis. And now if we sort of clean it up just a little bit, we can see that we are now to where we want to be, because we are at 1 over 2 minus x. Okay, so if we're going to graph, we're going to need to work through this progression. We're going to need to start here by graphing our original function. We're then going to need to do a horizontal shift 2 places to the left, and then we're going to need to reflect it over the y-axis. So let's look at what this looks like for our graph. All right, so here we see our original graph, 1 over x, and we see what the graph looks like. Then we see this graph shows the shift 2 units to the left. So you can look at the entire graph as being moved over 2 units to the left. And then here we see the reflection over the y-axis. So we see this piece of the graph flipped over, and we see this piece of the graph flipped over here. And so this progression shows the sequence of transformations that needed to occur to go from 1 over x to 1 over 2 minus x.